Morning and welcome to Building the Future 2020. It's an event where you will hear about newest innovations in the construction sector. I'm your host, Daniel Kiessling, and I'm a scientific officer at the Bavarian Research Alliance, your one-stop shop for EU funding. At the Bavarian Research Alliance, we give hands-on support for your grant applications in case you have a Bavarian partner inside your consortium. And in most cases, we can do this even free of charge. The event was originally planned to take place in the Ministry of Economy of Bavaria, but now, due to the current circumstances, we decided to have an online event, and this opens the event up to an even wider audience. We have currently over 100 registered participants. Today, you will hear about latest developments in policies directly from the European Commission. You will hear about several EU-funded research and innovation projects, their results, and also about the processes there. And you will get an insight into top innovative startups that might be interesting for you for future collaborations. Now, in the upcoming 3 hours, the event takes place from 10 to 1. We will have 2 sessions divided by a 10-minute break. And after each talk, you will have the possibility to ask questions using the questions panel that you see in your GoToWebinar application. The questions will be collected and moderated by my colleague Caroline from the Forschungsinstitut für Wärmeschutz, and she will present the questions to the speakers. If we are not able to answer your questions within this time frame, we will forward them to the speakers and they will be able to answer you after the event in written form. We will record the sessions, and hopefully, if everything goes right with the techniques, then we will be able to provide you with the recording. And for everybody who agreed to be on the participant list, there will be a list of participants available, as well as all the talks given today. Now, Building the Future 2020 marks the final stage of a research project called InnoVIP, a project about vacuum insulation panels. And I'm happy to now introduce you Christoph Sprengard, the coordinator of the project InnoVIP, who will give you a short word of welcome and a first glimpse into the project InnoVIP. Christoph, you're up.
Good morning, everybody. Ladies and gentlemen, it's my pleasure to welcome you as well to this online event. Actually, as Daniel said, we planned it as a dissemination event for the results of the InnoVIP project, as an event in the Bavarian Ministry for Economics. But as things happened this spring, we have to have it online, and it's also a new experience for me to present in a webinar. But nevertheless, it's not my job today to give you all the results. I leave that to my colleagues who did the technical work in the project. We from FIW were the coordinators, and we more or less, together with some partners, initiated the project a few years ago. So my job today is only to give you a little or a small overview on the problems that we face when we use vacuum panels in the building sector. For example, you know, a vacuum panel is something that is quite sensitive to punctures, quite sensitive if used in a rough building environment. And of course, to maintain the vacuum, it's not possible to cut or machine these panels. So therefore, we have to find a way to fix them without penetrating them with fasteners. We need an exact planning for the panels to be used on site. And even sometimes we need a numbering of the panels in the plans just to place the exact panel number 2, 3, or 4 at the place where it is foreseen to be in the plan as number 2, 3, or 4. So this in fact makes it not very easy to bring something like a prefabricated element like the vacuum panels are together with a building environment that is more or less something that people do with their hands on site. But as we like challenges, this is not the only one we have. There's also one specific thing with vacuum panels, that their thermal performance is not the same in all areas of the panel. So as you can see here in the right picture, we have panels laid on a roof terrace, and you still can see there is snow in the middle of the panels in the center area, and the snow has already melted at the edges. So meaning that the total thermal performance is influenced by the center thermal performance, but also by the edge effect of the panels, where we have the aluminum foil surrounding the edges of the panels, and where we usually have something in between panel and panel to avoid scratches and so on. So that's also something that we have to have in mind when building with vacuum panels. On the market, there are several types of panels, especially in the building sector. The fumed silica panels are used. They have rather small pores. It is a more or less expensive core material, and therefore it needs a very tight foil, but a foil that is avoiding too much edge effects. We will see that later. So low edge heat losses and a better performance, meaning overall performance and a better durability. And for the time that you expect that a panel is going to last in a building life, then we need more time for the application in buildings than we need, for example, in the application as household appliances. And in household appliances, another type of a bit cheaper panels are used. They make use of a core material glass fiber, which is cheaper but needs an even tighter foil, where pure aluminum foils or foils made from solid aluminum are used. But they show higher heat losses at the edges, and therefore, depending on the panel size, they might even end up with a total thermal performance that is a bit worse than the one of fumed silica panels. But they are perfect for the use in household appliances, where you have a life expectancy of in between 12 and maybe 15 years. So this is the ideas and the challenges behind the Innovate project that we were going to tackle with it. And especially if we have, as we have environmental aspects to consider as well, we were going to improve the thermal performance by using silica cores, but in a more efficient way. We were going to improve the edge effects and also come up with a solution for fastening the panels. To make these panels more environmentally, or make them better in an environmental way, it is one idea to reduce the material used, because the LCA from these panels is more or less depending on the amount of core material, which is one of the most or has the biggest impact on the LCA of the panel, together with some parts of the production of the foil. But also we had in mind to improve the durability and the service life. And this is connected to several envelope developments that we had. For example, UH co-extrusion, or the use of barrier lacquers, or even aluminum patches in the center area of the panels. To make them more usable in the building environment, we were providing protective layers for the panels and also protective stripes in between the joints of more than one panel. Having edges made from another material that is outside the envelope, meaning could give us an opportunity for a secured mounting and also for an easier fastening of the panels on the building. So this was the starting point for the Innovate project, but also we had in mind, of course, VRPs are a rather expensive building material, and therefore we have in mind a dramatic cost reduction, coupled, of course, to the core material density reduction. The less we use, the less it costs. A faster and better production process, and of course also a second alternative to have an even cheaper core material, and that's the core material perlite we were up to. The developments we were examining for the project on the envelopes were giving us the opportunity to produce them cheaper, but even more gas tight. So something that has a double positive effect. Finally, the project is cared about the easier use and the multifunctionality, where we have a fastening concept and using the cover layers, but also additional functions like antibacterial, antifungal, and also moisture control and fire retardant coatings that we were using. That's about it, and those were the starting point for the project. And now I will give the floor first to the European Commission for the Horizon Europe and the Green Deal part, but then afterwards also to my colleagues from the technical working of the Innovate project that did the daily work and did the technical developments, and they will show the results of the project and what they really achieved during this development. Thank you very much for now, and if you have questions, please feel free to ask. Thank you.